NASA launched its largest and most powerful telescope into space on Christmas Day 2021. The James Webb Telescope arrived at its final destination in the cosmos about a month later, on January 24, 2022, and will orbit nearly 1 million miles away from the Earth. The telescope will spend 5 to 10 years studying the formation of the universe's earliest galaxies, how they compare to galaxies today, how our solar system was formed, and whether or not there is life on other planets. In this video, we will tell you all about the James Webb Telescope, and the difference between it and other Hubble telescopes. We will also share details about the exclusive new images of the telescope and the latest controversies around it. Make sure to watch this video till the very end so you don't miss anything. But before we start, make sure to give this video a thumbs up, subscribe to our channel, and press the bell icon to stay connected. So, let's get started. The history of the James Webb Telescope. NASA, the European Space Agency, and the Canadian Space Agency all collaborated to build the Webb Telescope. Thousands of engineers and hundreds of scientists from all over the world worked together to make this space technology a reality. Its development began in 1996 as the Next Generation Space Telescope, before being renamed in 2002. The James Webb Telescope is operated largely by NASA, which provides the majority of its funding, with partners including the European Space Agency, ESA, and the Canadian Space Agency, CSA. The telescope is named after James E. Webb, one of NASA's early managers who directed the establishment of the Apollo program in the 1960s, according to NASA. James Webb's telescope name was first given to what was previously referred to as the Next Generation Space Telescope in 2002, nearly 20 years ago. That decision was later called into question as the James Webb Telescope launch approached, with many scientists arguing that Webb discriminated against gay and lesbian NASA employees during his time as an administrator, and thus should not have his name affixed to the high-profile observatory. The telescope's construction was completed in 2016, but it required extensive testing before it could be launched. Numerous setbacks and delays, including a redesign, resulted in a $10 billion cost. However, with the new technology used in the cameras, it can see celestial bodies like stars, nebulae, and planets that are too small or too far away to be seen by the naked eye. NASA announced in September 2021 that they would not rename the mission. Webb was supposed to cost $500 million and be ready for launch in 2007, according to The Atlantic. However, given the spacecraft's enormously complex and innovative design, these estimates proved to be overly optimistic. According to the US Government Accountability Office, the telescope's construction cost nearly $10 billion, nearly doubling the estimated cost since 2009. Even so, the scientists involved in the project believe that the results will surpass the time and money invested in it. NASA is emphasizing that Webb is more than just a bigger and more powerful telescope than the Hubble. While it is both these things with more than 2.5 times the diameter and 100 times the sensitivity, the James Webb Telescope is a different type of instrument. As previously reported by Live Science, ordinary optical telescopes see in the same part of the spectrum as our eyes, covering a wavelength range of roughly 380 to 740 nanometers. The Hubble telescope covered all of this, as well as a little bit further into the ultraviolet at shorter wavelengths and infrared at longer wavelengths. NASA has communicated through their website that the James Webb Telescope will be equipped with a brand new infrared camera called the NIRCam, Near Infrared Camera, which primarily operates with a wavelength range of 600 to 28,000 nanometers. As a result, it will be unable to see green or blue light, only orange and red, as well as a wide range of longer wavelengths beyond that. These very long wavelengths are more useful to astronomers than the visible spectrum for many astronomical objects, including star-forming regions, exoplanets, and the most distant galaxies. According to the University of St. Andrews, infrared poses challenges for Earth-based telescopes because much of it is blocked by our planet's atmosphere. The Earth's infrared sensor emissions true heat radiation, which tend to overwhelm the fainter astronomical sources. As a result, the best location for an infrared telescope is in space, as far away from Earth and all of its unwanted heat sources as possible. According to NASA's James Webb Space Telescope website, the Webb telescope will be located nearly 1 million miles, or 1.5 million kilometers from Earth, at the so-called L2 point, following in the footsteps of ESA's Herschel Infrared Observatory. This will provide Webb with a much clearer view of the universe than the Hubble has from low Earth orbit. But there is a drawback. Webb, unlike its predecessor, is not easily accessible to a repair team of astronauts if it does break down. Everything must work flawlessly on the first try, which is one of the reasons it has taken NASA nearly 2 decades to get the Webb ready for launch. How different is it from the Hubble? The James Webb Space Telescope does not resemble the Hubble in any way. Like a traditional telescope, the latter is enclosed in a cylindrical tube that protects the optics from stray light. Hubble can be exposed to a lot of light depending on where it is in orbit. Blazing sunlight from one direction, reflections from the Earth's surface from another, and sometimes even the moon. However, both Webb and Hubble are built on the same functional principles. They're both built around a large primary mirror, which has a critical job of capturing as much light as possible from objects on the observable universe's outskirts. In general, the larger mirror, the better. It is 8 feet (2.4 meters) in diameter and made of a single circular piece of glass in Hubble's case. If this was scaled up to the size required for the James Webb Space Telescope, around 21.3 feet or 6.5 meters across, it would not only be extremely difficult to fabricate, but it would also be too large and heavy to launch into space, according to NASA. Webb's mirror, on the other hand, is made up of 18 hexagonal segments that are folded up for launch and then deployed into an operational configuration once in space. Although NASA considered using glass for the segments, similar to the Hubble's mirror, they ultimately chose beryllium, a very strong, lightweight metal commonly used in high-speed aircraft and space vehicles. The recent released images and their meaning. On July 11th, President Joe Biden unveiled the first full-color image of the James Webb Space Telescope. The image, titled Webb's First Deep Field, depicts SMACS 0723, a cluster of galaxies located approximately 4.6 billion light-years from Earth. The galaxy cluster was chosen by astronomers due to its extraordinary mass. The galaxy cluster is so massive that it bends and magnifies the light of distant galaxies located behind it, allowing us to peer deep into the cosmic past. SMACS 0723, located 13.5 billion light-years from Earth, can be seen magnifying the light of some of the universe's earliest galaxies via this light-bending process known as gravitational lensing. Around the central galaxy cluster, those galaxies appear as warped, swooping arcs of light. Astronomers have already identified at least 2 galaxies in this image that could be the oldest ever observed. NASA released 4 more JWST debut images on July 12th. A spectrum image of a nearby alien exoplanet reveals the precise chemical composition of the planet's atmosphere, as well as several dazzling close-ups of enormous dust-shrouded objects from all over the universe. The Carina Nebula, a bright and gaseous hotbed of star formation located approximately 7,600 light-years from Earth, is perhaps the most iconic early image. Scientists have extensively studied this nebula, but the new image reveals the cosmic cliffs of Carina in greater detail than ever before. Hundreds of newborn stars previously invisible to telescopes shine through the nebula's grassy landscape. Dust jets and eddies swirl through the image, creating strange structures that scientists can't explain. Another well-known image depicts the Southern Ring Nebula, also known as the 8-burst Nebula, a figure-8 shaped cloud of gas and dust ejected by a massive dying star about 2,500 light-years from Earth. The stunning image depicts glowing orange foam of molecular hydrogen swirling around a blue haze of ionized gas, bursting out of the image's doomed star in the center. The revolutionary technology of the James Webb Space Telescope will study early stage of cosmic history. This telescope will help us understand the origins of the universe and our place within it. If that doesn't give you goosebumps, we don't know what will. And if you enjoyed today's video, please leave a like and don't forget to subscribe. Until next time guys, take care.